In a previous video, we introduced the idea of a unit circle when we were talking about quadrantal angles, the angles at 0, 90, 180, and 270. Now we're going to delve a little deeper into the idea of the unit circle. So let's return once again to our 30, 60, 90 right triangle. If I draw a 30, 60, 90 right triangle and label it as you were taught to label, the opposite side to 30 right here is 1, the adjacent side to 30 is square root of 3, and the hypotenuse is 2. But if I want to put that angle 30 degrees on the unit circle, I need to create a triangle where the hypotenuse is equal to 1. So I need to do a similar triangle. To create a similar triangle, I can divide all sides by the same length. So I'm going to divide all sides by 2. If I divide all sides by 2, then the ratio of the sides remains the same, and I have a new triangle that is still 30, 60, 90, but now its sides are all half as big as they were before. So 2 divided by 2 is 1. That makes the hypotenuse equal to 1. 1 divided by 2 is 1/2, so that's the opposite side there to the angle 30. And the adjacent side becomes the square root of 3 over 2. If you put the square root of 3 over 2 on your calculator and get the decimal approximation, you'll find out that this is about 0.87, and of course this would be 0.5. And the reason I did that is that you'll notice that this unit circle down here, we know it's a unit circle because it has a radius of 1, is labeled in decimal values. So I know that this is a 30-degree angle because of two things. The opposite side here is 0.5, okay, and 0.5 is 1/2. So the length of this side is 1/2, or 0.5. The length of the adjacent side then should be the square root of 3 over 2. And we found that the decimal equivalent to the square root of 3 over 2 is 0.87, or at least I told you that it is. And you can see that this length is about 0.87. So this is the square root of 3 over 2, or about 0.87. So this is a 30-degree angle, and the hypotenuse is 1 here. We also talked about earlier that if I'm going to plot the coordinates of this point right here, I would just need to find its x value and its y value. Well, the x coordinate here would be the square root of 3 over 2, or 0.87, and the y coordinate would be 1/2, or 0.5. So I can label this point the square root of 3 over 2, 1/2. And that would be in decimal form, that would be the same as 0.87, 0.5. And recall also from our previous conversation about the unit circle that the nice thing about a unit circle is that if the radius, or the hypotenuse, the radius, which would be the hypotenuse, is equal to 1, then when I do opposite over hypotenuse or adjacent over hypotenuse, I'm just dividing by 1. So the sine value of 30 degrees is 1/2 over 1, which is just 1/2, and the cosine value for 30 is square root of 3 over 2 divided by 1, which is just square root of 3 over 2. So these two values actually tell me the cosine and sine of the angle. So this is cosine of 30, and this number is sine of 30. We also know that from our original 30, 60, 90 right triangle, where we would say 30, the sine of 30 would be opposite over hypotenuse, 1 over 2, and cosine of 30 would be adjacent over hypotenuse, square root of 3 over 2. Now, that doesn't mean I have to stop using my triangle in its original form. So if you're doing a problem and drawing a reference angle, you can still label it this way because you get the same trig values. This is just a special way we label it specifically to put in the unit circle. Now you might think, what's the point of a unit circle? Why would I even bother to do that? Hang on and we'll get there. Right now let's create the unit circle, and then we'll talk about why it's kind of a useful thing to do. So the first thing I want to do, or the second thing I want to do now that we've labeled our 30, 60, 90 triangle in quadrant 1, is I want to also find all the other angles that would use a 30, 60, 90 reference angle. So what all has a 30-degree reference angle? So a 30-degree reference angle in quadrant 2 would be the angle 150. I can draw that by just reflecting this triangle into the other quadrant. So this point right here would would still have a y value of 0.5. I would drop a perpendicular line down and see that the x value is negative 0.87. So this would be negative square root of 3 over 2, but this stays positive 1/2. Since this is a 30-degree angle and all the way around here is 180, then this is 150. So here's 30, here's 150. Now how do the coordinates change? Well, the y-coordinate is exactly the same. It's still 1/2, but the x-coordinate has just become negative. So the coordinates of this point would be negative square root of 3 over 2, 1/2. Now, if we go down into quadrant 3, now we're basically taking this reference triangle and reflecting it upside down into quadrant 3. So if we go down like this so that our y-coordinate is negative 0.5 now, and our x-coordinate remains at negative 0.87, here would be a 30-degree reference angle in quadrant 3. And since I'm taking 180 and adding 30 to that, this would be the angle 210. The only difference between the coordinates in quadrants 1 and 2 and quadrant 3, and in quadrant 3, both of the coordinates would be negative. Negative square root of 3 over 2, negative 1/2. Now, going over into quadrant 4, this triangle would reflect over into quadrant 4. We could think of the triangle in quadrant 1 going upside down into quadrant 4. So we're going to extend this down. Notice we're still at negative 0.5 on the y-axis here. If we draw a 30-degree reference angle, since this is 360 when we go all the way around, if I subtract the 30-degree reference angle from that, this would be 330. Now when we write our coordinates here, notice that the x-coordinate is now positive while the y-coordinate remains negative. So this would be positive square root of 3 over 2, negative 1/2. So I'm going to rewrite this one because it's hard to tell that the 1/2 is negative. So all of these have the same numeric, like the same absolute value for x and y, but just opposite signs in different quadrants. I'm going to add one more set of angles to this drawing. We're not going to put all of our angles on this drawing, but we're going to put the angles that have 60-degree reference angles on this drawing. So that would correspond to taking this little triangle that I made here and just tilting it so that the longer side is the opposite side and the shorter side is the adjacent side now. So 60 would be down here. So this side becomes 1/2. This side becomes square root of 3 over 2. A hypotenuse is 1. So I'm just putting it in a different position. So if we put that 1/2, if we go to the right 1/2 from the origin, you can see there's our 0.5 right there, and then go straight up, we're going to create a new set of triangles here. So go straight up. Notice what my y-coordinate is that 0.87, which would be the square root of 3 over 2. So here we have 1/2 in the x direction and square root of 3 over 2 in the y direction. I'm not going to label it all because it gets really crowded, but this coordinates of this point would be 1/2 square root of 3 over 2, and this would be our 60-degree angle. So we can do the same thing in the other quadrants as we did with the 30, is all I have to do is just reflect this over into quadrant 2 and change the x-coordinate to be a negative x-coordinate instead of positive. The y-coordinate stays the same. So if I go negative 0.5 in the x direction and then go up, I would end up right here. So negative 0.5 and then up. There we go. There would be my 60-degree reference angle. And since the difference between 60 and 180 minus 60 would give me 120, this is a 120-degree angle. It would have an angle of 60 between this angle and the x-axis. So this is 120. Its x-coordinate is still 1/2 but negative. Y-coordinate is still square root of 3 over 2. Moving down now into quadrant 3, I'm going to take this triangle and basically flip it upside down into quadrant 3. So the adjacent side remains negative 1/2, but the opposite side now is also negative square root of 3 over 2. This angle is 180 plus 60, so this would be 240. Its coordinates are negative 1/2, negative square root of 3 over 2. Notice the 1/2 and the square root of 3 over 2 switch places when we go from 30-degree reference angles to 60. The last one now is going back in the positive direction for the adjacent side, so positive 1/2, negative 0.87, or negative square root of 3 over 2. So we're down to here. The reference angle 60 would correspond to the angle 300. So the coordinates of this now, the x-coordinate of 1/2 is now positive, the y-coordinate is still negative, negative square root of 3 over 2. Now, you still might be thinking, what in the world are we doing with this? And we have to kind of build this up a little more before you'll see the whole pattern. But the big idea about using a unit circle is this. So this is the advantage of using a unit circle with radius 1. Oops, dotted my I twice there. So what's the advantage of using a unit circle is, one, the cosine value is just the x-coordinate on the circle. So if I want to know the cosine value of a particular angle, I just look at the x-coordinate corresponding to that angle. The sine value is the y-coordinate on the circle. This is going to be really useful when we look for a pattern to draw a graph of the sine and cosine functions. The cosine value is the x-coordinate, the sine value is the y-coordinate. So I'm going to stop here and then we'll pick up a short video to do the next part of this lesson.